Hi, guys.
Thank you.
Very good. Thank you.
All yours.
Hi there. My name's Tristan, Tristan Kuhl from Silicon Labs. Very happy to be here. It's our first time at Things. Glad to be joined by our partner at Qoitech and M.Sc. And today we're talking about energy harvesting. It's a topic I'm quite passionate about, and I'm glad to see it's getting a lot of attention at this week's conference. So normally, when I've given this presentation, I've done it dozens of times, I have to spend a few slides explaining why batteries are bad, why they're not sustainable, why they're hurting the IoT. And thankfully, I don't need those slides anymore. The message is clear, and our customers are doing this now. It is real. So today it's not going to be a what and why, it's going to be a how. So before I get into that, though, we should introduce the topic here, what we're talking about. When we say energy harvesting, we're all over the place. We're indoors, we're asset tracking, we're in buildings, we're in smart homes, we're in factories, and we're on the electric grid. And we're getting our power from indoor solar, outdoor solar, kinetic motion, heat exchange, vibration, induction, and we're using the IoT in a number of different protocols. Bluetooth, proprietary, WirePass, 15.4, Zigbee. So maybe you see yourself on the slide, but there are hundreds, if not thousands, of applications here, and we're going to show you how to design this. So the first step is understanding your sockets and understanding your energy flow. What device is capturing your energy, which device is transforming it, and which device is storing it. And then ultimately, what Silicon Labs does is use it. We're the IoT SoC. And when it's time to make that decision, it's understanding and choosing a system that is energy aware, that is dynamic, and that has optimized platform for waking up and going to sleep and controlling your peripherals. So it sounds complicated, and in fact it is, but it doesn't really have to be. So the challenges with this, and we want to make this easy for everybody so you don't abandon these fantastic products, is that there's, like I said before, many different energy sources, many different protocols, and honestly, more and more partners, which is good. They're emerging, and we love partnering with them. We can't do it by ourselves, but it makes for a very complex design selection. And furthermore, once you do get there, because you're reliant on energy harvesting, you often have to prototype an environment like this, which could be dangerous, which could be noisy, could be dirty. So it's a challenge to get your product to market in a reasonable time. So what did we do about it? Silicon Labs and our partners developed this kit that fits in your pocket, and you'll see it on a few booths across this conference, that allows you to explore each and every one of those sockets. You can experiment with configuring your buck and your boost, your regulator. You can experiment with all of the fantastic harvesters, all of the fantastic storages, and it makes this really easy to prototype. And it allows you to follow a more conventional approach that you're more common with. Understanding your energy budget, understanding your peaks, your max, and then ultimately when you get to the IoT, we've provided loads of documentation, loads of videos, loads of reference designs, and we encourage you to come see it. I'm going to pass the floor so we can get a bit more technical to my colleague here, Björn, who's going to show us some exciting demos with this kit, in fact.
Thank you, Tristan, for that. So what I'm going to show you is how to move from methodology to practice. So how easy it is to start evaluating energy harvesting systems. So I'm going to show you how this is done for real, and what I am using. I have different parts. So I'm using, of course, the Silicon Lab energy harvesting kit, and I'm using a PV cell from Voltaic Systems, together with the energy storage in the form of a lithium supercapacitor. I am also using our own OT ACEs, two of them, to monitor the energy flow that is in the system, to be able to see how the energy flow and to see how much energy you can actually harvest. So, starting with evaluating the PV cell. Evaluating PV cell and evaluating storage, it's also about evaluating power management IC circuits. So the power management IC is its job with the PV cell is to harvest as much energy as possible at given conditions. So for example, if the light changes, it's the PMIC's role to always keep getting the maximum amount of energy available. And it do this through maximum peak power tracking, and it is typically done by releasing the load, measuring the open circuit voltage of the system, of the PV cell, and then getting back with the load to a set value. For example, 75%, all of this is settings inside the power management IC. And when the light changes, the set points also need to be changed. So this is done constantly. Whenever the light changes, the PMIC needs to work to get a new set point to get as much energy as possible. And this needs to be tested. So it must be tested in different conditions. There will be different light conditions, so you must measure how much energy is possible to harvest in different conditions, and make sure that it actually works. So this is critical, doing a long-term measurement to see the variations that will appear in the system. For example, the PV cell, it will, in the real world, it will get dirty, there might be scratches. They will change the efficiency of the harvested energy. This is pretty easy to verify, to measure at the different conditions. What is difficult is to do this for long term, but we have the tool to make a really long measurement to see the variations over time. And the next part is then to evaluate the energy storage and to make sure that you have large enough storage to store the energy. Because you cannot only do this theoretically, because you can calculate how much energy that you can gather from an environment. But for example, when the storage is full, the rest of the energy is wasted. So you cannot add all this available energy. You must make sure that you can actually store it as well. And to make sure that you have enough energy, you must see the different conditions. For example, there could be periods of low light, like night time, or worst case, northern Sweden in the winter time, almost no sun at all. You must make sure that for your application that you can actually harvest enough energy for the functions for the low light periods. You will also need to verify the efficiency from harvest energy into the storage. There will be efficiency losses there, so you should verify this for the different voltage levels that the system will see. So you make sure that you have high efficiency. Also for energy from the storage to the consumer, the IoT device, there is also efficiency that needs to be verified. So you will be able to measure the energy coming in and out to do the calculations to see the efficiency. Also, the storage must be evaluated in the same way as the PV cell. There will be aging effects, like when you have energy charging and recharging the cycling, it will change the behavior of the storage after a while, so you must make sure that you can handle the changes in the possible capacity that can be stored. This also changes with different temperatures. Then you should look into the total picture, that you can harvest enough energy for your use case, to look at the big picture, because there will be things that happens that you didn't expect, of course. And one very important thing of this is to look into the device side. You must have the device in itself, the radio, optimized, because this is the starting point. If you don't have that optimized, it will put really high requirements on the energy harvesting system. But if you have the device side optimized fully, then you get a lot lower requirements on the energy harvester. So this means that you should measure and make sure that you can handle the different use cases for on the device side. For example, you might want to have a firmware over the air update. Then you must make sure that you have enough energy and that you have calculated this in your energy budget. Also, for example, if you have something blocking your transmission path, that the device goes up in a higher energy state to transmit, make sure that you also have take coverage for that. And to make this very simple, Silicon Labs has its energy harvesting kit, and Mouser has this all put together in a kit solution. So if you scan the QR code, you will find a solution that makes it easy to start this evaluation. And do that already today. It's very easy to start doing this.
The kit's on the booth. It's been told it's been running all week without dropping a packet. It's been working all day.
Exactly. So if you want to see this live, come visit us in B21. We have it set up. We can show you the energy flow, how easy it is to start working with energy harvesting. So thank you so much.
So much.